All right, so let's try number 17 out of 11.5, which is roughly kind of something about associated behaviors. So first things first, and they say this in probably the most precise and slightly confusing way possible. They want you to suppose n is a constant. Okay, so n's some number. And then they want you to note that f of x is a function defined when x equals n. The heck do they mean by that?
When's x equal
Yeah.
on two functions.
Yeah, so really all they mean is n, which is x, makes f of x defined. Meaning n's in the domain of f. They really could have just said n's a constant and f of n is defined. That kind of makes sense? Right, I know f is a function, and what they mean by of n is defined is they mean you can fit n into the function f. So then they're asking me questions about, like, A says f of n is big, then 1 over f of n is, well, what's 1 over something big?
Really small. Really, really small.
Something small. So for part B, they want f of n is small, then 1 over f of n is, yeah, if I take one thing and split it into a small number of, yeah, that one's weird, right?
A little bit.
So 1 over something small is big. Okay. If f of n is 0, then 1 over f of n is
Possible.
good, undefined. D, if f of n is positive, then 1 over f of n is positive. And E is, if 1 over f, or sorry, if f of n is negative, then 1 over that is still negative. Does that kind of make sense?
Oh, yeah.
They're just looking for you to kind of complete the sentence in the, or to describe this associated behavior. The reason they want you to do this is sometimes when I've got, like, okay, so say I had, for example, f of x is 1 over x plus 2, right? I want to graph this thing, or I want to think about the asymptotes. So what do you know about this function?
X cannot be negative 2.
Yeah, x can't be negative 2, right? It's got a vertical asymptote at negative 2. Okay, there's negative 2. All right, so then I might wonder, what's the long run behavior? Like, if I go out, right, making x big, then this is 1 over something big, right, which is small. So I know that my function kind of tails into 0 on the right-hand side. What does it do on the left-hand side? Over here.
Oh.
Like way over here. So that's 1 over something negative and big, right? Doesn't matter, it's still small. But I could notice that I said it was negative and big, right? So I know it's both small and also,
You said negative and big.
so 1 over negative big, right? This is small and also negative. So I know it's not this top tail end. So I know it must come up from the bottom. This other guy, over here I'm thinking about 1 over a big thing, right?
That's positive.
That's positive. So not only is this thing small, but it's small and positive. So I know it can't be this tail. You guys see that? And then in here, near negative 2, I can think, what if I plugged in a number that's just a little bit bigger than negative 2? Well, yeah, so I'm kind of on this side, I'm thinking 1 over like negative 2 plus a bit plus 2. So the negative 2 and the 2 are going to cancel, and then there will be like a bit that's positive. Right, so I'll have 1 over small and positive, which is going to be big and positive. So I know my tail goes up there. Same line of reasoning for something a little smaller than negative 2, right? I'm going to get 1 over something small, which is going to be big, and also negative. So I'm going to get this tail. And so my function looks like, big surprise, connect the tails. That's cool with that? So these things are super useful. I usually use them in a pair. Right? I don't tend to use the undefined one here, except to find that vertical asymptote in the first spot.
Yeah.
And then I think about these guys in a pair. So I think, okay, if something's big and positive, then I can maybe describe some kind of tail. Cool.